We have looked at the speed of sound and waves. Next, we should look at what is happening with the speed of light. Lots of you have probably heard of Einstein's famous equation, E is mc squared. What we need to realize is that the speed of light is c. That's the variable that Einstein's famous equation is based on c. And at the time, scientists didn't know really how fast speed had traveled. And there had been lots of experimenters trying to figure that out. Galileo, back in the 1600s, he and his coworker went to tops of mountains that were a couple miles apart and shone lights at each other and tried to record how fast it was when you turn this light on, and when your partner saw it, would turn on their light and they would record the time it took. And because speed travels so fast, it wasn't an accurate measurement. But in Mount Wilson in California in 1927, a physicist by the name of Michelson earned himself a Nobel Prize in physics for calculating the speed of light. And he got this number here, 299,792,456.2 meters per second. This is a picture here of Michelson standing next to Einstein. So this guy was pretty brilliant to figure this out. And the number that he had is pretty close. Today, scientists say that this is the exact value of the speed of light in a vacuum. Unlike sound waves and even the water waves had to travel through a medium. Light waves don't need to. And that's what this means about in a vacuum, is it actually can travel through nothing. And it does travel differently when it goes through different materials. But when it travels through air, we're pretty close to this number. So maybe you're asking, how long would it take light to travel a distance of 1.5 kilometers? Now remember that the speed of light is, I'm going to round it off here. I'm going to go 3.00 times 10 to the power of 8 meters per second. Because the velocity is in meters per second, I'm going to convert this into meters. So there's my distance in meters. And I'd like to know the time. Well, we just go back and use our very simple formulas that we did before, that our speed is our distance divided by time. And that works wonderfully if things aren't changing as they go. And so if I want to find the time is the distance divided by the velocity. So in this example that we have, our time would be 1,500 meters divided by, and let's see, what's it divided by? 3 times 10 to the 8th. Looks like that. 1, 2, 3, right there we go. So meters per second. And if you're good with this stuff, you could even, I'll write this in scientific notation, 1.5 times 10 to the third divided by 3.00 times 10 to the 8th. And I can do the quick mental math on that. That's not hard. 1.5 divided by 3, well, that's a half. And if I know my exponent rules, times 10 to the negative 5th. Now, that's not proper scientific notation. So let's see, that would be 5.0 times 10 to the negative 4. There we go. But those of you that are going to use your calculator, you're going to see it's not taking it very long to go 1.5 kilometers, 0.000 1, 2, 3. There we go. Oh, it's not meters, it's in seconds. Similarly, if I want to calculate the distance that something travels in a certain period of time? Well, I've got a time here of 75 minutes. Once again, I'm going to put that into seconds. So I know that 1 minute is 60 seconds. So my time in this problem will be 4,500 seconds. So my velocity is distance over time. And if I want to know my distance, the distance will be the velocity multiplied by time. So the distance would be 3.8 times 10 to the 8th meters per second times 4,500 seconds. Wow, how far in one period of school, when some of you as students are sitting in your chairs not doing much, how far has it gone? It has gone 1, 3, 5, 0, and some zeros in there. Just to put it in perspective, it has gone from Earth to the moon and back, right to the moon, 1,756 times. Big distance. Speed of light, it's a constant. It does not change, although the media that it goes through will cause some variations. But in air, we are easily within acceptable ranges by rounding that off to 3 significant digits.